Hello everyone, welcome back to the channel. In the last video, we demonstrated how to turn a manual-centric request for quote process that runs every quarter into a highly streamlined process that only requires human-in-the-loop for critical review and decision-making, leveraging the capability from agentic AI workflow. We went through step 1, which automates RFQ email sending to the company's product suppliers. We also covered step 2, which corresponds to Jira tickets label value step 1.1, where an automated scheduler monitors supplier responses and sends chaser emails. Following from the previous video, today we demonstrate how to set up Jira ticket step 2 to 5 of this hypothetical process in n8n. Let me do a quick refresh of how Jira tickets are set up for these steps. In step 2 tickets, they share a common Google Archive folder destination to store final supplier quote response. Each of the external emails represents who we expect to receive the response from. Step 3 ticket only has an archive folder to store the best offer proposal. Step 4 ticket external email field is set up to store all the manager's emails so a management review meeting can be automatically scheduled. Step 5 ticket external email field indicates who I should expect to receive the meeting minutes from, and the archive folder is where the approved minutes will be stored. In Jira step 2, we want to monitor all the incoming emails from the suppliers, while in parallel the step 1.1 scheduler is monitoring supplier response progress. The email monitoring leverages AI to detect whether the supplier's response is asking additional questions or just providing status updates. These are the situations where AI will leave human to conduct further correspondence with the suppliers. When AI detects the supplier's response contains the price and product functionality information that company requested, it will initiate a human-in-the-loop checkpoint. AI will forward the supplier response to the company's reviewing analyst for confirmation. Only when the supplier's response is confirmed by a human, the workflow will resume to archive this response in a Google Drive folder. Once each supplier's response is reviewed and confirmed, the workflow will close step 1 and step 2 Jira tickets. Now let's review the workflow nodes setup in detail. In the first Gmail trigger, you can connect it to any account where you expect to receive supplier emails. Typically, this will be a central company address that you use to communicate with your suppliers. You can also customize the polling frequency, which I set to 1 min currently. You can further customize the supplier's email filter if they are expected to come from certain email domains. Remember enabling the download attachment option, given we expect the suppliers to send price and product information in Excel or CSV format. The next 3 nodes are similar to what we demonstrated in step 1.1 workflow. The Gmail trigger is always monitoring incoming emails when running in production. For efficiency, we don't need the trigger workflow to continue if there's no active RFQ process in progress within the quarter. These 3 nodes are set up to early stop the workflow, so it doesn't waste production computing resource. If the RFQ process is active, we extract the process name from the supplier's email. The extracted process name is compared to the active process name that's stored in the process demo database table within n8n. Only when the process name in the supplier email matches to what's in the database, the workflow will further proceed. This mechanism prevents the workflow from processing emails unrelated to the current RFQ process. Now, once these preconditions are validated, we retrieve the Jira ticket related to this supplier's response. We first retrieve the step 1 ticket, which is about RFQ email initiation. These tickets are currently under awaiting response status. We need this ticket to be memorized during the workflow so it can be closed when we reach the end of the workflow. The JavaScript code node is used to parse out this information for later use. We then add an AI chat message node. This node is instructed to check if the supplier's response is a regular Q&A or status update email or provides the price product information the company requested. For the former, the workflow will do nothing, while for the latter, the workflow will initiate a human-in-the-loop checkpoint. The AI prompt in the demo is relatively simple, but of course it can be expanded to cover what your real requirement is. If AI determines this is a real price/product response, it will forward the supplier email to me for review. The code node is necessary to carry forward the supplier email's attachment, given the attachment received by the initial Gmail trigger is not automatically carried forward along the n8n workflow path. We now have everything needed to send the email to me, the review analyst, to review and confirm the material. The subject, attachment, who sent the original email are all embedded in the email body. Note the email also contains callback URL that the review analyst can click to approve or reject the response. This callback URL works in conjunction with the wait node that we will discuss next. The wait node serves as a time stopper in this workflow. It allows a human analyst to take time and review the supplier's response to confirm AI's determination is correct. The wait time can be customized to days, hours, minutes, etc. to meet various needs. The WAPSC suffix is a value that gets attached to the callback URL associated with the approval or rejection link that the review analyst will see in his email. In more complex workflow setup, this suffix can be used to differentiate callback activities and make it easier to debug errors. If the review analyst rejects the supplier's response, the workflow ends and the Jumble trigger continues to monitor the next email. If the supplier's response is approved, we first use an edit field node to bring forward the process name and the email body forward in the workflow. As explained before, n8n doesn't automatically bring data from multiple prior nodes forward, except the immediate prior node, so we need these intermediate nodes to act as temporary memory storage. We find all the step 2 review and archival to do tickets by calling the get Jira child tickets tool. We use a code node to filter out the ticket matching the supplier's email address. Next, we create a parallel branch. One uploads the email attachment to Google Drive folder. The other branch converts the supplier email into PDF. Here I use the HTML to PDF node from Part2, which offers both free and paid tier plans. The email PDF then gets uploaded into Google Drive based on the archive folder stored in the Jira ticket. The two branches are executed in parallel to save time. Then we need a merge node to combine the branches back into one. Now step 2 review and material archive is completed, so we will use a Jira node to update the step 2 ticket to the done status. Similarly, in parallel, we use another Jira node to complete the step 1 ticket. The edit field nodes at the end of the workflow are optional. I use it to pass information back to the WAPSC response, which is what the wait node will get when the review analyst clicks the approve or reject button in the email. For anyone interested in adopting this demo in more real-world use, feel free to change the setting. I will now demonstrate how this workflow runs with supplier email responses. I've created 3 emails representing 3 different suppliers, each with some product price and functionality information attached to the email body. I also created an email with supplier question so we can show how AI differentiates email intent in the workflow. I will send the question email first. Now let's trigger the workflow. You can see the execution stops after the isSubmission node as AI detects it as just a Q&A follow-up. I will now send all the real price quote emails and then trigger the workflow 3 times. When running in production, given the Jumble trigger can run frequently, it will automatically pick up new incoming emails. This time the workflow will continue to run until it hits the wait node. At this point in my email, I should expect to receive a forwarded message from AI asking me to review the supplier's response and approve or reject it. Here, what this email looks like in my account. The message introduces it as generated by AI and requests human-in-the-loop checkpoint. It attaches the original email body and attachment for my review. Once I click approve, the workflow resumes and performs the archiving of these responses. It finally marks both step 1 and 2 to be done. All 3 executions of the workflow require a human analyst to review supplier response before final archiving. However, with AI and automation, humans' focus has shifted from doing all the steps to just reviewing and decision-making. Now let's check out the archived document in Google Drive. In the Step 2 folder, you can see all 3 companies' quote attachments and original emails getting archived automatically. With proper automation, this saves all the manual hassle of downloading emails and attachments and then uploading to this folder to archive, greatly enhancing productivity. We are moving on to review Step 3 workflow setup. Step 3 works together with Step 1.1 and 2, but acts as the final coordination closer once all the supplier's responses are received and reviewed by the review analyst. Once all the price and product information are confirmed to be valid, the workflow will pull all the archived information together and let AI perform a best offer comparison analysis. While the demo only has 3 offers, in reality it can be expanded to analyze tens or hundreds of offers instantly, while a manual effort will usually take much human coordination and days to complete. Once AI finds a best offer supplier, it initiates a human-in-the-loop checkpoint by notifying a human to review the result. Once the human manager reviews and approves, the proposed best offer gets archived and Step 3 Jira ticket is marked done. Now let's examine the workflow node setup details. The initial trigger node and the 3 nodes that check if a RFQ process is currently activated are the same as what we reviewed in Part 1 of the video for Jira Step 1.1, so I will not repeat it here. The real workflow starts with the Find Tickets node, where it calls the Jira child tool to find all the Step 2 Jira tickets. Since different suppliers may respond with different time, we query all the to-do and done tickets in Step 2. Given the best offer analysis only starts when all the supplier responses are collected, which means all Step 2 Jira tickets are in done status, we use the code node to check whether this condition is met. Once all the supplier responses are done, we find all the Excels archived in the Google Drive that contains the price and product functionality information and download them. Given AI cannot directly perform best offer analysis on Excel data, we use an extract from file node to convert Excel content to JSON object. We then use a code node to parse the JSON into a format that's more readily understandable to AI to process. The AI node is instructed to iterate through all companies' product offers in a JSON array. The best offer for simplicity's sake is defined as the lowest cost per functionality. In reality, more complex customized logic will likely be needed. It generates a winner recommendation and lists all the suppliers offering an HTML table for ease of human review. The overall process status in the process demo database table then gets updated to pending offer review from activated. Note by changing the status, it also indicates to step 1.1 and 2 workflows that they don't need to continue execution. This way we save some production computing efficiency. The workflow then sends an email to the human manager with the AI proposal for review. It then stops on the wait node and waiting for human approval. The human manager approves the AI proposal. The workflow calls the Jira child tool to find the step 3 ticket that is in to-do status. It uses an edit field node to carry over a list of fields in the workflow memory, so later steps can use these fields. For example, the archive folder is needed for the AI proposal to be stored into. The HTML input and file name are needed for the PDF generator to convert the AI proposal into PDF for Google Drive upload. The HTML to PDF node simply needs the HTML input and file name from the prior node to perform the conversion. When the PDF is generated, a Google Drive node is called to upload the file. Note the input data field name refers to the binary PDF data, while the file name field is derived from the file name stored in the binary PDF. The archive folder ID tells the Google Drive node where to upload the file. Once the file is uploaded, we introduce a Google Drive search file node. This node finds the web view link for the AI proposal document we just uploaded. The link is useful for step 4 when we set up management review meeting. The document link can be included in the meeting invite for ease of access. The web view link gets stored in the edit field node for temporary memory preserving. The final Jira node marks step 3 to be completed and responds back to the wait node. This now marks the completion of step 3. I will now move on to step 4 workflow setup, which is about automating senior management meeting schedule. This step happens immediately after step 3 completion, so it is a natural extension of step 3 workflow. We store all the manager's emails in the step 4 Jira ticket, and we use the Jira child tool to get the details of this ticket. And here is the tool's parameter setup. We then use a JavaScript code node to define the time period during which we would like to arrange meeting with the senior managers. Here we specify that we want the meeting to happen between New York time 9 a.m. to 5 p.m., and it should happen in the next 3 days. The list of manager emails is also combined into the code node's output for Google Calendar query. The Google Calendar node is set up to process this JSON input to find all the managers' availability during this predefined time window. Once Google Calendar query finishes, it returns a JSON object containing a search start timestamp, a search end timestamp, and a busy data object containing each manager's email and busy time blocks. We instruct AI to find the earliest 30-minute availability window where all attendees are free. We also ask AI to provide a reason of the schedule proposed in case there's a need for another human checkpoint to review the scheduling proposal. For demo purpose, we simply take the AI suggestion, use a code node to parse out the suggested start and end time of the meeting. We then set up a Google Calendar node to create an event based on the AI suggested time slot. Here the start and end time in the Google Calendar node are from the AI suggestion, the attendees are from the emails stored in the Step 4 Jira ticket, and the best offer proposal document file link from earlier Step 3 workflow is also embedded in the meeting invite. Once the meeting invite is sent, the workflow moves Step 4 Jira ticket to be done status. I will now demo how Step 3 and 4 workflows work together. First, I will tweak one of the Step 2 ticket back to to-do status so you can see the workflow stops at the check All Done node. Now let me execute the workflow, and you can see it indeed stops there. Once I switch all the Step 2 tickets back to Done status, the full Step 3 and 4 workflow will execute all the way through the end. Let's wait a little bit. It now stops at the Wait node, waiting for me to review and approve the AI proposed best offer. I see the email in my inbox which lists who's the best supplier and rationale. It also lists all the other suppliers' offerings for ease of human review. Once I approve the proposal, the workflow resumes to complete the rest of step 3 and send me back a webhook response. In the background, the workflow proceeds to execute step 4 of the workflow to arrange management meetings. When the meeting is arranged, it moves step 3 Jira ticket to be done and updates the process status in the process demo table to be pending minutes. Now let's look at the Google Calendar. You can see a Q4 process event added to the earliest available 30-minute slot that all the managers can attend. While the setup in the demo is simple, a real production workflow has the capability to handle much more complex situations. The last step in the whole process is minuting the management discussion, submit it for manager review and archive. While minuting meeting discussions can also be automated using AI, that's not in the scope of this demo. We use a Gmail trigger node to monitor incoming emails that may contain meeting minutes. Similar to prior workflow setup, if the current process status in the process demo table is not pending minutes, this workflow just sits there idling. If the process status is moved to pending minutes, it uses a code node to examine email subject to ensure it's an email about meeting minutes and extract the process name, e.g. Q4 process, from the subject. The workflow compares the email subject's process name to what's stored in the process demo table as a second filter to prevent unnecessary execution. Following process name comparison, the workflow calls the Jira child tool to get step 5 ticket, which should be in to-do status. The step 5 ticket stores information which analyst is supposed to write the minutes, which is a third layer of filter. The subsequent if node compares the email sender address to what the step 5 ticket email info and decides whether to forward this minute's email for manager to review. In reality, multiple of these filters can be further simplified and combined if anyone would like to use this approach for production purpose. The workflow will now forward me the minute's email for review, similar to how similar human-in-the-loop checkpoint works in earlier workflows we reviewed. It stops on the wait node for me to respond. Once the minutes is approved, the workflow resumes. It carries forward necessary fields in the edit field node, which are used by later nodes. The PDF node converts the email meeting minutes to PDF. The PDF file then gets uploaded into Google Drive based on the archive folder information stored in Step 5 Jira ticket. Once the meeting minutes PDF is uploaded into Google Drive, a Jira node is used to mark Step 5 ticket to done status. The overall process status in the process demo database table is then updated to completed status. Now let me quickly execute this workflow to show you how it works in action. I will send a fake meeting minutes email first. Now run the Gmail trigger. The wait node now waits for me to review the minutes. I click approve and the workflow continues and I get an all steps completed webhook response. In the Google Drive Step 5 folder, we also see the minutes archived there. This now marks the end of the full 5-step process automation demo. To summarize, we demonstrated how to automate a 5-step manual-intensive process using AI+n8n workflows. During the automation, the key human pain points are eliminated, such as manual chaser and meeting scheduling or documentation archival. With proper arrangement of tasks leveraging tools like Jira, AI+n8n workflows are turned into efficient project managers to coordinate how the process should move forward. With AI and workflow automation, it also reduces the change of human error or missing steps. The automation still respects the importance of human-in-the-loop control. However, the human role is uplifted to a higher level of the value chain. Analysts or managers who used to focus on scrambling through manual task execution due to time constraints can now focus on reviewing material and decision-making, while the underlying tedious data collection, iterations with suppliers and documentation archiving are all outsourced to AI and automation. Now, what does this give us in terms of next steps? The demo itself makes simplified assumptions, so by no means is a production-ready plug-and-play. However, given I've shared the full setup in GitHub, feel free to grab a copy and play and modify as you see fit. The more important point is for process owners, regardless of whether you are in big or small companies. With the acceleration of AI and automation capabilities and that you have access to them, a lot can be achieved with short time turnaround and low costs spent. The subscription fee associated with the tools and AI models I used in this demo is a tiny fraction of what it would normally cost an IT department in a company would charge. Also, there are many other tools out there that can probably develop this demo even with pure natural language instruction, so the opportunities are huge in this new AI era. Leave feedback in the comments section on how you would suggest further enhancement to this demo or any other idea you would like to see a demo for. See you in the next video.
See you next time! Wow!